Now, when I talked to you before about the for range loop having a value and a pointer semantic form, it actually goes a little bit deeper than what I showed you, and I really want you to see this. Again, most Go developers, even if they've got a couple of years in, don't realize how deep these data semantics go, and they're so important at a micro level to keep your code consistent and clean. So let's take a look at our range mechanics now, and you can really understand why I'm saying that one form of the for range is value semantic and one is pointer semantic. And let's just define this again. Value semantics means that every piece of code is operating on its own copy of the data. We get benefits of that data isolation around mutation, right? We get data locality, which is going to help us later on with some performance around multi-threaded software. It's just cleaner when we can use those value semantics, but it comes with a cost. Nothing is free, and that cost is inefficiency. And then we have the pointer semantics, which means that we're going to only keep one copy of the data, and it's going to be shared. And there's a lot of efficiency with that. But at the same time, we have to worry about these side effects. We've got to worry about mutation a lot more. So let's take a look at this first block of code here. And I'm going to throw some print statements in here, because I don't want you to see the output for anything else right now. So we're going to throw these in, and we're going to look at it. And one thing you're going to know about me is I don't like to play games. I don't like to trick people with code. I want all the code that we look at to be readable, and I want you to be able to understand it. Remember, understanding that code means that we understand the cost. So here we are in line 12. And on line 12, what I have is this array of strings, and the strings are pre-initialized. You can see we're using that literal construction like we did with the struct. We're using it now with the array. So we're doing a construction of 5 strings, and we're initializing it with Annie, Betty, Charles, Doug, and Edward. And then we're displaying the string at index 1, which is going to be Betty. Again, we're not tricking. I'm not trying to trick you at all. Now, if you notice here, we're using the pointer semantic form of the for range. We're just asking for the iterator here. I will start at 0. So in the very first iteration, we're going to go and change out Betty, which is at index 1 over here. We're going to change out Betty to Jack. So now there's no more Betty there, there's Jack. We ask if we're in that second iteration. Right now I is 0, the answer is no. We range back over, I is now 1. We change Jack back to Jack. I didn't say this code was efficient, I just said that we're changing it. And now I is finally 1, and we display this string at index 1. So what would you expect to see? Well, this print statement should be Betty, because we haven't touched anything after the initialization. And then we change Betty to Jack. We iterate a second time. We change it again, and we display it. And sure enough, we see exactly what we expect to see. We see Betty, and then we see Jack. Again, notice that this is the pointer semantic form of the for range. OK, great. Let's go look at the value semantic form of the for range now. Here it is. And again, we have the same exact array. There it is, Annie, Betty, Charles, Doug, and Edward. We display Betty again on line 26. There it is. We display Betty, and then we go through the same iteration, but this time we're using the value semantic form of the for range. And on the very first iteration where I is 0, remember, V is a copy of every string, we change Betty out to Jack. Same exact code as before, and we are absolutely changing Betty out for Jack. But I isn't 1 right now, it's 0. We come back up. Now I is 1. We change Jack back out again as Jack. Remember the same thing we did before. This time I is 1. But when we make a copy of that string, remember on the second iteration we'd already changed it. But when we go to display the value in index 1, you'll notice that it still says Betty. Now you might be wondering, whoa, what's going on? We definitely changed Betty out to Jack. Why is it not being represented? Let's reiterate one more time. What does value semantics mean? It means that every piece of code is operating on its own copy of the data. And when I talk about this for range being value semantic, I'm not talking about V. Though V is an aspect of the fact that we're making a copy, it's not V that I'm talking about. I'm talking about the fact that this for range isn't iterating over the friends array in this case. It's actually iterating over its own copy. Think about this. Copy. And so we are absolutely changing out Betty to Jack. But that's not the array we're iterating over. We're iterating over our own copy of friends at this point. And so any changes to friends is irrelevant in terms of this iteration. So remember, when we say it's a value semantic form of the for range, we're saying that the for range is operating on its own copy of the data. That's the only way to get the value semantic, to be honest with you, right? The whole idea of value semantic is that if we're operating on our own copy, we're working on our own copy of the data. It's a safe place to be, not just reading, but also the writing, right? Which is the part that we're worried about. So when we are using this form of the for range, we're operating on our own copy of whatever it is we're iterating. When we're operating on this version of the for range there on line 15, that's our pointer semantic. Now we have to index in, we have to index into that array. Here we get to operate on a copy. In fact, if you think about it, V is a copy of the copy, isn't it? Which again is what we want inside this loop, because every piece of code should be operating on its own copy of the data. These data semantics are so important. We're going to continue to talk about them throughout the rest of this almost really entire video series from beginning to end, because it's your data semantics that are going to allow you to have code consistency. They're going to allow you to grow a code base. They're going to allow everybody on the team to know what they can and can't do, what they should be looking at, what they don't need to look at. They're so critically important. They're so embedded into this language. You're going to continue to see this more and more.